Welcome everybody. As mentioned by James a little bit, the idea of today is going through the ecosystem of solutions that we have created around the subsurface, right? So as I call it, it's about mapping the reality that cannot be seen. My name is Gorka Santamaria. I'm the senior product manager for this product line called Geomatics. Right, I've been with Screen Eagle for roughly 3 years now. And started this whole project from the beginning and been involved in the geomatic industry for more than 15 years altogether. And the idea of today is really first starting to have I will just give an introduction on what is the historical background of mapping the subsurface, what standards to apply in different countries, and what are the traditional workflows, just as an entry point into what is our solution, what is our ecosystem, that in the end what it does is enabling a digital workflow in the field within a larger connected ecosystem, with the aim of, in the end, producing the dream of the industry, which is a digital twin of the subsurface, right? And then at the very end, where we will reserve some time for questions and answers. So let me first start with the first chapter. So mapping the subsurface. So as you all know, we are present in the geospatial industry, and that means every corner of our planet, nowadays, whether from terrestrial systems or even from satellite systems, every corner is, roughly speaking, mapped and has been mapped, whereas what lies beneath remains a mystery, right? And there's some initiatives, but still it's not a space that has been mapped to the day. Right, and we have now looking very, very concretely into what is below. Typically, what we have, or the main element, is there's a complex utility network, right, with all the services that in the end provide our day-to-day, which are often disrupted by events such as strikes, which have a huge cost. Estimations are, we're talking on the billion level, and that happen to a big extent because there is no accurate or up-to-date maps of the underground, right? Just as a side note of this, the 90% of all the damage occurs in the first 2 meters. That's where you can find cables, where you can find fiber, where you can find small gas pipes, to the houses themselves, and that's where most of the accidents happen. To tackle on this problematic, over the years and over the decades, in fact, there have been many national standards and guidelines. Many have been created over the years, right? And here we could mention a few that are kind of the standards in the area. So we must mention here the British PAS 128, and then many other standards that are closely related to it, right? So the national standard in France, the national standard in the US, national standard in Canada, national standard in Australia. There's also national standard in Malaysia, and more countries are picking up on this. All of them, in the end, look into the same exact concept, right? Which is about having some, or defining some quality levels for the detection job, right? So what have the technologies or the methodologies and techniques used in doing so, and what are the accuracy levels that have been achieved both in 2D and in 3D, right? So in the end, what it results into is into a tabulated way of looking at a detection or geodetection job, right? The golden standard in the industry because, because obviously excavating is not always possible. So when we look at it from a non-destructive perspective, then we could typically say the goal is to achieve the best possible non-destructive detection method at the highest accuracy level, right? And that's defined with complex graphics like those that you can see on the left-hand side. But in the end, we're talking typically two main non-destructive techniques are used to locate utilities, right? So those two techniques are GPR, which is a underground scanner, and then the EM tracers, which are more like a point-to-point detectors, right? So what we typically say is in most of those standards, a B quality level corresponds to the maximum level that can be detected and mapped without direct exposure. Now let's look at the bit of GPR, right? So first of all, what is ground penetrating radar? Most of you would know it. It's an acronym for, GPR is an acronym for ground penetrating radar. In some areas, it's also called georadar. It's a geophysical survey method that uses electromagnetic radiation to image the subsurface in a non-destructive way. So just in a very simple explanation, what you have is a signal emitter and receiver, and that generates kind of a radar image of the underground as you go along it, right? And typically when you have an object such as a line, as a pipe, then that will return as hyperbolas. So let's look at what is the history of utility locating. As mentioned, there are two main non-destructive techniques, which are the electromagnetic locators and GPR. Typically, the job of a locator consists on combining these two techniques and placing spray marks on the ground, as you can see on the right-hand side in the image. So there is a person that is putting those spray marks on the floor with technique number one, with technique number two, and then the excavator comes and digs. Just a plain fact, after digging, this knowledge gets lost. That's the status quo of how the industry works, right? It produces spray marks on the ground. After digging, this knowledge gets lost. If we would digitally map those findings, the information loss could be prevented. However, today, what is the reality? The reality is this. So in the end, what you can see here is multiple equipment, too many steps in the workflow, too many tools, too many technicians, and often poor accuracy. Those are the long-lasting pain points of the industry, right? And those, to a large extent, are the ones that explain why the subsurface is not mapped, why it is not possible to scale up in that process fast enough or quick enough to cope with the global demand, right? So this is the history or the background on this industry segment, and the one that we have carefully looked at and kept in mind when designing our products and our ecosystem, right? So let's jump into the second step or the second block of this presentation, right? Which is about having a digital workflow in the field, which is what we aim for. So let's go back to this image. As mentioned, the workflow in the field is the following. There is a technician number one that uses a pipe locator and places some spray marks on the ground. This is electricity line, this is electricity line, just point by point, right? Then before or after, I mean, in any order, I mean, it could be before or after, there's a person that locates using a GPR card and marks the ground. Same exact process, just that this comes from radar information. Typically, for this to be mapped, a third technician would come to the field, and hopefully those spray marks are still on the ground. He would collect them using survey equipment. That's step number 3. And this is not everything. This is just part of it. As a 4th step, I mean, and whether this implies sending a USB stick from the field to the office, in the end, a fourth technician, the CAD technician, and he looks happy in this image, but he may not be that happy, is the one that will be responsible for merging all these field data of different sources, different types, to a CAD and produce digital utility maps, reports, deal with coordinate systems, and all of that. Right, so this is actually what happens every day in many places in the world. Now, this is what we wanted to tackle. And some of you may have followed a little bit the historical evolution of our GS solutions. Some of you may be completely new into this. But essentially, in October 2021, what happened is all of the GS8000 systems in the market were automatically updated over the air, right? And obviously this also applies to to the current GS8000, right? So what we did was, let's say, a major release of the software, and this is purely a software update that enabled a lot of potential that was on the GS8000 already. So now if we remember the image before, I went through 4 separate steps, right? That's how the industry is working. So after this update, not only the GS8000 was able to produce radargrams, radar information, including a very, very, very high resolution image in the first 1.5 meters, so in the area where it matters, right, which had been the technological advantage of the GS8000 before that moment. But actually what we did was go to the next level. And that means we were able to produce not only radar information, but actually to give you in the field a very understandable and meaningful image from the top, right? Like a heat map of the subsurface. You could look at it as this is like a Google Earth image of the subsurface where you can move your slider up and down and see what happens at different depths, right? Described in an understandable way. Just graphically, you can see, okay, here there's a map, some utility lines clearly forming in this street crossing with a correspondence to the radar information, which in the end it's like combining step 2 and step 3 of the image that was shown before. The app is also able to produce the necessary maps out of it, so you would be able not only to see the heat map that derives from the radar information, you could also see all the annotations and tags that you would do on the radar translated into the map on the right, at the right depth. On top of that, you could also digitize the markers that you could have obtained from the electromagnetic locators and incorporate them into the same map in the right coordinate system. So that is like combining the step number 1, step number 2, and step number 3 in one single system, and even the step number 4 with a direct conversion into the most usual CAD, GIS data formats, right? So with this, you would ensure that even the person number 4 in charge of merging all of this data doesn't need to really go through this, but just incorporates a CAD layer out of the box into their CAD system or into their existing GIS system, right? So this is essentially what we enabled. And guess what? Even the most impressive part is not the fact that all the steps of the workflow can be attained with one system, but it's actually the fact that it can be done in real time. And here, when I mention real time, I really mean 100% real time. So let's have a look into this video, right? I load my coordinate system, I load my satellite maps, and what I'm actually doing is, as I move, I'm creating, or I'm seeing the underground in front of my eyes. So I can very clearly see, okay, this line is aligning with this, in this direction, this other line is aligning in this direction. I can, at any moment, adjust the depths, adjust the section that I'm seeing, start digitizing on that space, and just continue scanning, right? So the results of the scan are produced in real time out of the box. So this is what we call free path. Free path, it's actually it's bringing into the real time, bringing into the 3D space, the scanning process and the heat map of the subsurface that will help you understand better what is just below your feet. So if I analyze this, in the end, in terms of what it brings to you, in the end, it's several benefits, right? That translate as value. One is, there is no need for preparation before starting to scan. So you just connect your device and start moving, as opposed to having to run exploratory scans or having to set up a grid, which many of you may have done in the past, and it's, as you know, very time-consuming step. And it also provides complete freedom to fit confined spaces or shapes as they come. So what you can see on the right-hand side, scanning a urban space where you have some squares, some strange shapes, you can really accommodate that without having to plan for different jobs and having to plan for different grids, right? You can run all of that in once and just get your results in front of your eyes. That's the benefits of start scanning out of the box. Fundamentally, a lot of time and flexibility. As mentioned, we can provide a subsurface heat map plotted in real time. In real time, meaning exactly in the same second as you're collecting data, right? So that completely erases the uncertainty level. So there is no more guesswork based on your radar information alone, right? The radar information helps interpret, but the radar information is not the only source of truth. The heat map is the main entry point to the data, right? So there's no uncertainty. Real-time heat map that updates as you scan, and very easy interpretation with 2D and 3D views perfectly synchronized. And then the next step is, of course, once you have collected all of this information and right in the field, this is no need even to go anywhere else, just in the field you get your full image of the underground. So there you can just, you know, pan and zoom as you would do with any survey system. You can play with your, you know, your slider, go up and down, see what's happening at different depths, fix it there. This is, as mentioned, a result of interpolating all of these scans along the, in this example, it's more than 2 kilometers of data, so pretty big data. You can place your annotations the same as in real time. You can also do it afterwards. They will appear in the map. Any moment you can jump into traditional radar information, get more detailed view or less detailed views. One gesture, get radargrams in a migrated form. One gesture, go back to the map. You can also run mapping functionalities, such as here, I'm going to mark a telecom line. I'm going to draw a, you know, electricity line. And all of this, I could just, I mean, here I have even a bigger one, which is a drainage line or gas and oil line, whatever that gets drawn. If it happens at the same time in the radar, it will show. And all of this information is synchronized in real time to the cloud, right? So I could export my CAD, I could export my GIS, and I could export a report that will automatically come to any device where I'm accessing the data from. In this example, I could just get my iPhone and get a report just within seconds, transported over the cloud. Right, so this is essentially the bigger picture of what we are trying to bring to the market in terms of a digitally connected ecosystem. Right, so if we look again at this, I mean, these steps that I went through, in the end, it's the ability of digitizing and sketching directly on the map, which means all in one. It means the findings from the GPR scans can be digitized, as well as findings from your electromagnetic locators, as well as other surface findings, let's call it a manhole, can be all digitized at the same time. And this is very important. No conversions. It means not only they can be digitized, but actually they can be digitized in the same map and in the same coordinate system. What we have done is our solutions come equipped with the complete EPSG coordinate system library. So that's the one that applies to all GIS systems, right? So if you've ever heard of a coordinate system that has an EPSG code, and those EPSG codes are in the GS solution out of the box. That means before I start even collecting any data, I can set my system to that particular coordinates that apply to, let's put an example, that apply to the southeastern part of Australia, to the state of South Wales, whatever, right? And every single pixel in that image, every single object that I find, every single line that I trace, the values are recorded not only in reference to the center of the Earth, but they are also recorded in reference to that particular coordinate system, right? So for example, if I go back to the previous image, in this report where you can see this tag, electricity has this easting and this northing, that is in a particular coordinate system, right? And this tackles very much on what the guy number 4 had to do in the office before, right? So all of this comes streamlined directly from the field over the cloud. And as mentioned, that means literally one click, right? So it's direct reporting. So the most common CAD and GIS deliverables are pre-embedded in the solution. And not only that, there is also the space for all the collaboration aspect. So let's put just an example. If you, in your office, you have another person that is running the same iPad, or it's running a different iPad, the person from the field can just share a link with you, and you will get a one-to-one copy of that job that is generated in the field in your second iPad. And you can keep on tracing, you can keep on drawing, you can keep on mapping also from the office. It's not, I mean, the information is not limited to the iPad, so all the reports and the raw data are also accessible from different platforms, right? So you could get your report into your iPhone, you could access your data almost instantly also from the web, that means from a computer, that means from this iPad itself, that means from a third ecosystem, doesn't matter. There is a web access to this raw data, and you can perform the conversions also from there. And as mentioned, it's not limited to the raw information that traditionally would need a GPR post-processing package to be processed, such as segue, but actually out of the box, you can get a copy of the job in Google Earth, a copy of the job in the right coordinate system in your CAD, a report as defined by the user, a shapefile to incorporate into your GIS ecosystem, right? So this is really the bigger picture of what we are placing in terms of a solution or ecosystem, right? So let's refresh our minds. What we mean is actually you start moving with your GS8000, that's the hardware bit. When you are doing it, you get an exact copy of what's happening below. In your iPad, you get this heat map. So you can complete your job, you can see your lines forming, you can digitize already while collecting data, or you can do it afterwards. There is no restrictions on when to perform the mapping step. And you end up with some results according to your CAD standards, where you can, okay, at different depths, you can find different findings, different tags, different lines. All of that is ready to be exported to your platform of choice. Okay, so just to summarize, what we brought to the market is a massive improvement on the subsurface mapping workflow, where today or until today, this required typically for big steps and often different equipment and often one dedicated person per step, one with the initial exploration and sometimes even setting up the grid. Then the scanning process in the field, which is essentially acquiring data blindly and then performing some marks on the ground. The mapping typically performed by a third person who comes to collect those marks afterwards, and then the merging all the data in the office in order to produce the reports, right? Which translates as lots of time, uncertainty, money, and hassle, right? So this is how the industry is working today, and how we believe subsurface mapping should be done is reducing this into scanning, mapping, and reporting with real-time results in 3D and 2D for an optimal interpretation, with all mapping aspects digitally and accurately mapped on the same map, on the same coordinate system, and with reporting done in one click. All in one same platform, field to client, streamlined workflow. That's how we believe subsurface mapping should be, and that is the step that we took in October 2021, where all GS8000 systems were automatically updated over the year to comply with this belief. And as mentioned, this is what relates to the GS8000 in itself. But when we look at it from the perspective of, okay, capturing the underground, the non-visible reality on a larger scale, we also need to look a little bit beyond that, right? So let's start with the GS8000 anyway. So technologically, what we are incorporating into the GS8000 is far more than just a GPR, right? The GS8000 is a combination of 4 fundamental elements. So it's the multi-frequency GPR with its card, yes. It's the incorporation of the geopositioning solution, and again, geopositioning is you know, it's a little bit more than just a GPS. It's also coordinate system handling, etc. And it's all powered by the app that runs on iPad Pros that you have seen, and is what essentially enables all the potential for the solution, right? So first of all, some of you may be already aware, because this has been the reality from the very beginning of the GS8000. What we did was incorporated a technology called step frequency continuous wave, which what it enables, as opposed to traditional GPR, which is centered around 1 or 2 frequencies, and therefore it's optimized for certain boundary conditions, such as, you know, if you have a frequency of, let's say, 400 megahertz, then you can get this amount of depth, and then the resolution is this. If you get an antenna of 2000 megahertz, then the resolution is much higher, the penetration is much less. What we try to do is to leverage on this technology that we had already developed in the concrete space, which what it does is span through a very large bandwidth of frequencies to, at the same time, be able to detect small and closely spaced target, typically in the first meter, meter and a half, and at the same time to find the standard few meters of depth, depending on soil conditions, that apply to most utility systems, right? So going back to the standard, to the images that apply to all standards, as mentioned before, we are providing an answer to the classical trade-off curve of, you know, accuracy, detection. At the same time, we incorporated, as mentioned, the integrated precision mapping. So it means there is a GNSS receiver, which, I mean, a GNSS receiver cannot get more than metric precision alone, but because it is connected to the iPad and the iPad is connected to internet, then we can get 2 additional things. So one is real-time corrections. So the system is compatible with RTCM3, which is a standard in the RTK world. And just through that, you can bring the precision level below the 5 centimeter mark. But that's only the precision. The accuracy is a factor of being able to map everything in the right coordinate system, right? So the M8000, the geopositioning bit not only attains the right precision level, but also will be accurately matching your existing maps. And last but not least, there is this connected digital ecosystem and data flow, which again, some of you may be familiar with, some of you not. I mean, we call that workspace. That's the space where all data gets synchronized to in real time. So essentially what you have is an app in the field that is always up to date, and the data from the field get synchronized to workspace within seconds, as long as you have an internet connection, right? So then those data become available for the client, available for other colleagues in the company in whatever desired output format directly from that platform. There is additionally one step that is also incorporated into this platform, that is the advanced data analysis. So you may have heard of this. I mean, a few months ago, we completed the acquisition of a company called GPR that was very advanced software for GPR processing, mostly in an academic environment. And what we are doing is gradually translating this into a more user-friendly user interface that sits inside workspace. That means my data from the field, which get in real time synchronized to workspace, at this point, this step, they can be processed with GPR insights, perform the advanced data analysis that is needed, that those data get updated with much more information or much more detailed advanced information, and still the same output supply to be provided to your client. So that's an intermediate step that is not needed in 100% of cases, definitely, but there will be certain types of jobs. I mean, I saw in the beginning that some of you reported that you work in archaeology, for example. I mean, archaeology is a field where this is heavily used, and then that would be easily integrated as an intermediate step. If we go back to the case of utilities, right, this example I provided before, right, so I can perform my field scans, I can even make my mapping in the field, but actually my goal may be not that. My goal may be, okay, we want to have an assessment, we want to know how good our current as-builds are, right? So those as-builds are in a particular coordinate system. So all I need to do is I load my field data into GPR Insights, and I load my existing as-builds also in the right coordinate system into GPR Insights. And here I can just have, I mean, just in this image, you can see this is a direct one-to-one comparison of existing as-builds versus the reality scanned in real time with the GS8000. And with this, you can have a very good understanding, okay, is this matching or not? Are my as-builds good enough, or do they need to be updated? Right, so this is actually quite, it's quite a simple process, right? In this case, it would just be, loading. I mean, this information gets in real time, loaded into GPR Insights, my field data. Then I would just here import, my CAD files in the right coordinate system. That's kind of an additional layer of information that gets loaded. You can see it's very fast because it's running on a very fast server in the cloud. All of this can be loaded, checked. I can also load my imagery, my satellite, and get a full overview on everything just in the same platform, the same ecosystem. Right, so this is really, really powerful functionality that we are also enabling. And just to finalize on this, I mean, obviously we are not only looking at, non-destructive technologies, but often the reality is exposed, right? Let's imagine a case, I mean, there is a new gas pipe that has been constructed, and now there's a trench open. That gas pipe is there. So at this point in time, I need to map it. Probably the most effective would not be using non-destructive technologies because it's already exposed, it's already available. So some of you maybe again have heard of our Inspect platform, and we are equipping this with more functionalities, and among them, one that is very interesting for this space is the 3D scanning, right? So just with your iPad, all of this information can be scanned, can be meshed. You can see it's a very simple process that anybody can just complete within a few seconds. And in the end, this translates as, okay, complete my scan, a little bit of processing, and what I get is a one-to-one copy of the underground reality, where, data are correctly dimensioned. So we can see it, those values really can be measured directly on the image, and this belongs to a specific location. So to say, should there be any kind of needs to document what has actually been done, that information can also be living in the same exact ecosystem, in the same platform, right? So we are really completing all the different sub sections of the workflow that happen at different points in the lifetime of an underground project, and really putting all these pieces of the Lego together in one connected ecosystem, right? So just to say, what we are doing is enabling and getting one step closer to the dream of the industry, which is having a digital twin of the subsurface. Right, so this is pretty much from my side, a little bit the topics that I wanted to cover today.